Hello. My name is Val. Today is the ninth, ninth, day number 9 of my daily marathon, where I solve leetcode problems using PHP programming language. Today is another medium problem, and topic is the same as yesterday: bit manipulation. Problem is called minimum array int. We are given two integers and an x, and we have to construct an array of positive integers that has exactly n elements, and this array should be increasing, and not just any array, okay? And the result of bitwise AND operation between all elements of x should be equal of nums should be equal to x. And then we are asked to return the minimum possible value of the last element, nums with index n minus 1. Okay, problem statement is quite short. The goal of the algorithm is not so straightforward. However, one of our peers has created very nice scheme to help us to understand what's going on. So basically, x is the number that we should get as the result of bitwise operation, bitwise AND operation on all elements of the array. And here we have green bits where we have ones and or set bits, and pink bits where we have 0. So the idea of the algorithm is to produce an array like this. Why? First of all, we have to generate the minimum possible array in terms of the value of the last number. So we are trying to minimize every number that we are putting in that array. And also, since bitwise AND should return exactly x, what does it mean? It means that through all the elements of the array, any of those elements should have ones on the same positions as x has, right? It can have ones on other positions as well, but it's not allowed to have zeros on the positions that have ones in x. And also, we should have at least one element for each position of x where it's not set, the bit is not set. We also need to have 0 here. So we cannot have, for example, here we cannot have all ones, right? We should nullify all the unset bits in x. Nullifying means having at least one element that has 0 in the same position as x has. So how we are going to calculate this? We will basically take this array and fill it with the bits of the number n minus 1. So in this case, we have we don't have n equal 6 in the example, but this is actually the case when we have to produce an array of 6 elements. We will first of all we will write small function that does something like binary representation of number, say key, okay. Binary means start with empty array, and then we shift bits one by one. Let's test this function on x. Let's see what our script produces. Yeah, it's not what I really intended, because we need to output x binary here. So here in the first case, we have x equal to 4. And this is the binary representation of that 4 in the reverse order, starting with the lowest bit. Here we have x equals 7, and this is the binary representation. Yeah, it's palindrome, so it can be read left to right, right to left, no matter what. Okay, let's also convert to binary form the number n minus 1. And minus 1 is the last element of the array, actually, the last index, and also now we will modify. We need to insert all the bits from n binary into x, but not just on any places, but on the places where x has zeros. So we are going to iterate through n binary. And now our goal is to put current bit into x, but we cannot put it just anywhere. We need to find a position for that. Initially, position is equal to 0, but it doesn't mean that we can put on this position the bit that we need. It's not. It doesn't mean that position is available. So we need to find available position. Available position is position where x has not a 1. So if we have 1, it means that we can move to the next one. Here we are guaranteed to have 0 on x binary position for in two cases. Either it's case like this, 0, 0, or this actually we have no space here. We are adding the new bit on to the end of the array, and we are putting n binary current bit of n binary array like this. Let's see what do we have in x binary. In the end of this operation. Here we have 5, and we should have 6. Here we have 15, and we also have 15. But why do we have here 5? Yeah, I know why. We forgot to move to the right because we are rewriting the same position multiple times here. We should do it like this. We should move to the next bit so we don't write it 2 times. Now we have 6. As we should. Okay, so now our goal is to convert x binary array from binary to decimal. Power of 2, we start with 0 power, so the value is 1, and we iterate through. Actually, let's do it slightly different. Let's go through all of the bits of x binary, and let's increase decimal by power of 2, and also we need to multiply it by the bit. So if bit is not set, we will ignore it. If bit is set, we will use the power of 2. So basically this is binary to decimal conversion from array to a number. Here we can return this decimal number. Let's see what we get. Yeah, we time limit exceeded means we have some loop that is not ending. This is actually I forgot to put count function. Sorry about that. Okay, let's run this. Hey, we solved it. Thank you very much for watching this. Please subscribe to this channel or like this video or dislike this video. Ask your questions in the comment section. Write your comments in the comment section as well. Please interact with this video if you want me to record more videos like that, or if you don't want me to record more videos, please don't interact. I will stop eventually at some point. Thank you.